lazy. Okay, so we added polynomials. We subtracted polynomials. Now we're going to multiply polynomials, and our goal in a little bit, so with numbers, we do like 3 times 2 is 6, and then to take it back apart. Now, division really is the inverse of multiplication. Like the inverse of multiplication is division. But what we're going to work on in this is kind of another opposite of multiplication. It's when you break it back apart into its factors. So, multiplication, factoring. Do you see how they're kind of opposites? Like it's undoing what you did, but it's not exactly the same as division. So, in the next 3 sections, after we multiply, so we work on multiplying, and then in the next 3 sections we work on taking them back apart, which is called factoring, because we're breaking it into its factors. So that's what's coming next. But factoring is a lot trickier than addition or subtraction or multiplication, so that's why it takes several sections to work on how to do it, and that's where we're going to stray from the book and move into worksheets from me, because I don't like the way they do it. Let me rephrase. I like my way better. So, there we go. Let's talk about how we multiply. It's not hard. I mean, we've heard of foiling things, right? Right? We foiled things before. Just in case this is not like your favorite thing, let's do a big one. 2x squared minus 3x, and then we'll do x to the third plus 7x. There's a big old thing. Here, in general, I will say, when we're multiplying, we have a binomial times a binomial. We're going to multiply them out. But generally speaking, if we have 2 things multiplied by 2 things, we expect 4 things. It may simplify later, like it might condense down some, but if we're doing bigger ones, that's a great way to keep track and make sure that we got them all. Like, because sometimes when you're doing longer ones, you might be like, oh, did I miss something? So a 2 times a 2 gives me 4 terms. And if you're doing a 3 times a 2, like if you had 1, 2, 3 of them times 2, we expect 6. So we make sure that we get all the terms, and then we combine like terms as much as we can. So here, the first, outer, inner, last business, the order isn't actually that important. The point of FOIL isn't to make sure you do it in the right order. It's to make sure you get all 4 pieces. So the order isn't what we should get caught up in. But generally speaking, so even for bigger ones, we do the first times the first, and then the first times the second, and then if there was another one, the first times the third. So you do the first thing times everything in the other parentheses. Then the second thing times everything in the other parentheses. So 2x squared times x to the third. Well, that's a 1 there, even if we can't see it. 2 times 1 is 2. And x to the second times x to the third is x to the fifth, because we add the exponents. That's our shortcut. Then the first times this one gives me 14, 2 times 4. X to the second times x to the first gives me x to the third. It's not hard, it's just tedious. Now, don't forget that this minus belongs to this term. So negative 3 times x to the third is negative 3, x to the fourth. And then negative 3 times 7x gives me negative 21 x to the second, because we had a 1 and a 1. So we 2 of them. That is 2 to 1. That's the sort of thing that drives me bonkers. Can we condense them at all? No, this is to the fifth, to the fourth, to the third, to the second. So none of them are going to combine. It's not super important to me that they be put in any particular order. They're fine like this. And then I'm going to do a slightly bigger one just for good measure. Plus y plus z times 2 plus, I don't know, x to the, ooh, let's make it big. Look at that, all kind of things. So 2 by 2 gave us 1, 2, 3, 4 terms. 3 multiplied by 2, 3 times 2 gives me 6 terms. So when I'm finished, I should have 6 things written down if I've done it correctly. So I'm going to take this x and multiply it by both of those. 2 times x is 2x. X times x to the fifth is x to the sixth. Why is it plus? Because a positive times a positive gives me a positive. Y times 2 is just 2y. Is it wrong to write it the other way? Is it wrong to write y2? It's not wrong, but it's confusing because we're not used to it, and your reader is going to say, is that y to the second? So traditionally we put the number in the front, but just for ease of reading. It isn't wrong to do it the other way. It's just tradition. Traditional 2 times y and y times x to the 5th. We again traditionally put them in alphabetical order. So we usually write x to the 5th y instead of y x to the 5th. But it's not wrong to write it the other way, so don't get too worried about putting things in the right order. So I've done x times both things, y times both things. Now I do z times both things, and I get 2z. And z times x to the 5th is, again, in alphabetical order, x to the 5th. Z just because that's traditional. And I got 1, 2, 3, 4, 5, 6 terms, which is what I expected to get. We can check real quick and see if any of them combine. They do not. If they did, we would combine our like terms together. So we might not end up with 6 once we put like terms together, but we expect to get 6 when we multiply it all out. Okay, what makes this hard? Like where's the trick? I feel like there's always a catch. Here's the catch. When you square things, it's almost a guarantee that somebody is going to try to go x squared plus 25. But you can't, we don't distribute a power that way. We sort of do. How about this? We do here, right? We kind of distributed the power. So what makes this different from this? This is addition. So remember that this power to the second really means times itself, right? A power is repeated multiplication. So all of this is multiplication. But this is addition mixed with multiplication, and that changes the way we kind of have to do things. So exponent first means we do this. And we have to, or our answer will be wrong. X squared plus 25 is wrong. So we have to FOIL it out, or multiply those two. We get x squared plus 5x plus 5x plus 25. 2 times a 2 gave me 4 terms, but my final answer, x squared plus 10x plus 25, when I combine my like terms, is this. So beware, they're going to try to trick you into giving x squared plus 25 or something like this, but it won't be. And anytime we have conjugates, that's a fancy word and I like it. These two are called conjugates. Look at them. It means everything's the same but the sign in the middle. That is not the formal definition. So conjugates, everything's the same but the sign in the middle. When we multiply, this is rocking and that is probably going to make the viewer seasick. When we multiply conjugates, something cool happens. We get x squared minus 2x plus 2x plus, minus 4. And the middle terms cancel out, which is kind of fun. But it doesn't really change the process of what we're doing. You still do it the same way. You still simplify the same way. But it is a cool thing to expect. That way we'll know that it should happen. If you have conjugates, everything's the same but the sign in the middle. The middle terms will cancel out and you'll end up with just the first and the last ones. If you're feeling real confident, you could shortcut straight from there to there because we know the middle term's going to cancel out, but I never feel confident enough to do that. Maybe you're more confident than me. I hope you are. I'll be confident people. All right, did they throw any other wrinkles in our plan here?
Yes. Challenge problems.
What? Where?
They do challenge problems at us. So by that,
Meaning you just don't want to do them, or?
Yes.
Okay.
I just set up 43.
Yeah, I'm struggling.
Okay. I did mention the cubing, but quickly, I'm not going to work the whole thing out, but just so I've said it. They do talk about a rule for cubing. That's kind of a shortcut to doing it the long way. They just give you a thing you can memorize if you feel like it. So if you feel like you can do this. So if we're cubing something, you can do it out the long way, and we can FOIL this part. Trust me. That's what it comes out to. And then you can multiply those two together to get the third thing. So x squared times x plus x squared times 1 plus, ooh, that gets long, doesn't it? 2x squared plus 2x plus x plus 1. So I multiply those two together, and then when I simplify a little bit, is that right? No, it's not. There we go. Oh, you can do it out the long way, and we're not going to do it very often, so it doesn't matter. But there is a shortcut, and I will point it out to you. It's in a little orange box on page 217. But here's the shortcut, generally speaking. You take the first thing and you just cube it, and that goes here. Then you take the last thing and you cube it, and it goes at the end. And then what goes in the middle is, I don't want to say it wrong. It's 3 times this thing squared times this thing. So in this case, 3 times x squared times 1. That's this. And then you kind of reverse that, but you keep the 3 because of the cubed. That's where the 3 comes from, the cubing part. So cube the first thing, cube the last thing, and then these two kind of take turns. So see how I squared this one, but I kept this one the same? The next time, you keep this one the same, and you square the second one. Times 3 again, sorry. So there's a shortcut if you're cubing something. To be honest, that doesn't come up that often. But just in case you would like to learn a little shortcut. So you cube this thing, you cube that thing. And then in the middle pieces, we go 3, which comes from here. 3 times that thing squared times this thing not squared. And then 3 times this thing not squared and that thing squared. They kind of take turns. In this term, this one gets squared and that one doesn't. And in this term, this one gets squared and that one doesn't. And that's the 4 terms that we end up with after all that other work. It's not always worth it to memorize the shortcut. Do you know what I mean? Like, it's almost harder to memorize the shortcut than it is to just do it out. If we were going to do a bunch of cubing, like if you were going to have a bunch of those problems, it'd be worth it. But you're not. So feel free to learn the shortcut as explained up there, or to ignore the shortcut and just do it the long way like the rest of us suckers. Okay, we said number 43. It says brackets. Get brackets out. Okay. Isn't that magical? So we're going to work our way from the inside out, because our order of operations says parentheses first, and so the more parentheses it's in, the higher it's ranked. So first, I'm just going to worry about this part. So I'm leaving the -1, I'm leaving this squared on the outside. I'm going to do just this bit. So 2x minus 1 squared is 2x minus 1 times 2x minus 1. Do you have to write that out? No, but it helps me to see it better when it's written side by side like that, but you certainly don't have to. So 4x squared, I'm going to go ahead and put my answer in parentheses, minus 2x minus 2x is minus 4x. Plus 1, because -1 times -1 is a positive 1. So that's what I get when I expand this part. Now I'm going to put my like terms together, because remember, still we're doing inside the brackets. We do the inside bit first. So I take care of this, and I have 4x squared minus 4x plus 1 minus 1, which means those go away. And now I need to square this part. I don't really need brackets anymore. I could switch. They're interchangeable for the record. Brackets and parentheses. The only reason we use both is to help you see it better. But they're both of their jobs is just to group things. And so they're interchangeable. You can swap them as much as you want to. You could have used just 2 sets of parentheses there. But when you're typing it in particular, so for the book, it doesn't really have different size parentheses. When you're handwriting it, it's pretty easy to do this. You know what I mean? Do like bigger parentheses. But when they're typing it, they can't really do that, and so that's why they always use brackets. But it doesn't matter which you use. That was a little bit of a detour, sorry. Bonus learning, providing value here. If they're ever like, which teacher do you feel like is giving you the greatest value for your tuition dollars? Feel free to be like, Miss Heather gives us so much bonus learning. 4x squared times 4x squared is 16x to the 4th. Then minus 16x to the 3rd minus 16x to the 3rd is a minus 32. I'm skipping steps. Plus negative times negative plus 16x squared. Yeah? I should mention while I'm here, they probably did too. Yeah. No? They did. There's a shortcut for squaring things too, and that one gets used more often, so I don't know, maybe it's worth it to you. So I'm going to do a real generic version. If you're trying to square something, it starts the first one the same way as that cubed rule. So you square the first thing and you square the second thing, but that's not all. In the middle, we go 2, again, it comes from there. So just like here, we did 3 times and 3 times. So we do 2 times the first thing times the second thing. So you can shortcut a square. And this one's worth memorizing because we square things a lot. I mean, does it save you that much time? Not really. So if you don't like to memorize, don't. But if this was more complicated, say, then I would square this. That's 4x to the 2nd. Square this. Negative 3 squared is positive 9. And in the middle, I go 2, first thing times the last thing. Now that requires a little simplification on its own. You could have done it in your head, but I get negative 6, 12. I think it's minus because it's going to be negative. Negative 12x. Is that easier? I don't know. It depends on who you ask. But I showed you. So now you can decide for yourself.
Can you see what the number answer to number 44 is?
If I can find it, I can. How many pages is that?
On page 218.
X to the 6th minus 1.
Start with that.
This assignment is 217, 43 through 49. A short assignment, but I gave you the hard ones because y'all been foiling forever and you know how to do it. So I picked the hard
I
one.
got X and
43 to
6
49.
plus